All right, let's start with something agriculture that is to do. A farmer wants to use a length of 2,400 feet fence to enclose three sides of a rectangular area where the fourth side is a riverbank. So he doesn't need to enclose that. Find a dimension that maximizes the area. Okay. So, here we go. A farmer wants to use a length of 2,400 feet fence to enclose three sides of a rectangular area. By the riverbank. And the riverbank is the fourth side. Okay. So find a dimension that maximize the area. The approach to problem solving, and I'll give you a little summary, but a mathematician, Hungarian mathematician by the name of Polya, wrote a little essay, short book, and I have the book. It's a wonderful book titled Problem Solving, Approach to Problem Solving. But basically what he says in the book, that there are certain steps that you need to go through. First step is, of course, to understand the problem thoroughly. So basically you obtain that by reading carefully. Second is you want to visualize the problem or the assignment. And the best way to visualize it is to draw a sketch. Then you want to convert it into mathematics. This is what we call modeling process. So you assign variables by determining first what is known and what is unknown to you, and then you determine the target function to be maximized. I mean, we want to maximize something. That something has to be a function. Now we know that a function has a maximum and or minimum, and this is by different theorems that we study, such as Fermat theorem and so on. And basically, we are after the absolute maximum in this case. So we need to check critical numbers and endpoints. Okay, so I'll write down those steps later on, but just to continue with this particular example, so let's sketch. So here's the river bank. So this is the river on this side, and you have some kind of rectangle like so. And you know this is the area, and you want to maximize the area. And now we need to assign variables. So let's say this will be our x, this will be our y, and this will be our y. And the area A equal, of course, x times y. Okay? And so the deal is to find x and y that give you maximum of A. Okay? So L, the length, is x plus 2y, and it's equals 2,400 feet. And now we want to, and of course A equals xy, so this is given to us. And what we need to do is find x and y that max a, like so. That's a kind of short way to write it. So if x plus 2y equals 2,400, then we can extract x and say, you know what, x equals 2,400 minus 2y. And now instead of having a expressing as a function of two variables, we can express a as x, which is 2,400 minus 2y times y, or 2,400y minus 2y squared. And now we need to maximize this function. But before we move on, let's think about the endpoints and let's think about critical numbers. Okay? So what are the endpoints? If you're looking at, okay, what will be the maximum length, x? Well, one maximum can obtain by taking the whole length of the fence and make it the length x. Okay, so x can be a value that goes between 0 and 2,400. Of course, when x equals 0, when x equals 2,400, the error will be 0. So the endpoints actually provide an absolute minimum, not absolute maximum. What about 2y? What about y? If x equals 2,400, then 2y equals 0. And if x equals 0, then 2y equals 2,400, or y equals 1,200. So those are the boundaries, those are the endpoints on y in this function right there that we are looking at. Okay? So obviously, how do you spell obvious? Obviously, the endpoint y equals 0 and y equals 1,200 produce an absolute minimum. So we're done with the endpoints. Now we need to find critical number of a equals 2,400y minus 2y squared. So we look at dA dy, we look at the first derivative, and we'll make it 0. We cannot make it undefined, so 2 dA dy equals 2,400 minus 4y, and we want it to equal 0. This happened when y equals 400. So this is the critical number. And now all we need to do is check to see if this produces a maximum. The easiest way to check is by second derivative test. If the second derivative is negative, then we are good.
Wouldn't y equals 600 if you want to 0?
It says 600. You just don't see well. All right. So, what about second derivative test? This is also an obvious thing, but just to go through the formalities here, d2a dy squared equals -4, and it's negative, therefore we have in a maximum, right? Therefore, the critical number produces a maximum. So the answer will be if y equals 600, x equals 2400 minus 2 times 600. So the answer will be x equals 1200 and y equals 600. Those will be the dimension that maximize the area. And of course, the maximum of the area will be the product of these two, which is 72 and 4 zeros. So 720,000 square feet. Okay, so this was a quick example